Now we will discuss the bus configuration. We will start with the mix bus configuration. The Axum mixer has 32 mono mix buses designed in pairs. So we have 16 stereo pairs. All these mix buses can have their own names and functions. If for instance sub is used, very often for recording, it is advisable to rename it into recording. In this demo we only use 8 stereo buses, which are in fact 16 mono mix buses. We've labeled them program, record, auxiliary 1, 2, 3, 4, dump and PFL. Bus 70 to 32 are not used in this demo. Per bus we can program functionalities of the bus. We can for instance program the PFL bus to receive a pre-on signal and also a pre-fader signal, which is logical for a PFL bus. You want to pre-fader listen pre-fader and independent upon settings in the module. The module balance is set to post, which means that a penpot movement will be heard in the PFL bus. A presetting will not give that information. We also can tell the software how the auxiliary level will function. Let's take auxiliary 4. In this programming we will choose post module on and pre-module balance. So the aux bus is dependent upon the module's on switch, but not responding to the balance of the module. Here the master bus level can be set. For radio is mostly 0 dB unity gain. We also can set the state of the bus, in this case on. In this programming we have a unity gain bus that is active. Interlock means we can set the PFL to be interlocking. Here we can set the PFL to be interlocked. I can imagine that when you push the PFL switch you want to hear only one module. This happens when you set the bus to interlock. In non-interlock, every PFL signal will be added to the first one you have pushed. In the exclusive column, we can select if we give the bus a special function. In this case, we have chosen to give the dump bus a special function called dump record. This functionality gives the bus a specific dump. That means that when the bus is activated on the module, all other modules on this bus will be deactivated and only the dump bus is active. This function is very practical for voice tracking. It works like this. Normally a mic is routed to the program bus or also maybe to an aux bus. The moment you activate the dump bus in this module, all other buses will be deactivated and only the dump bus will be active to make your recording. When the dump bus is deactivated, the former status will be activated before we decide to activate the dump bus. In this way we can make a recording in a very fast way on one or more modules and quickly switch back to the former state. Apart from this, we also designed another special function for the PFL bus. These are called communication technician and communication producer. This function gives the bus the extra functionality to work as a communication bus. If we give the PFL bus the functionality of a technician communication bus, the bus will automatically switch to the headphones of these persons we want to communicate with. The bus can be switched to the headphone outputs, but also to a hybrid output or an extra line output that is used for wireless reporters or a broadcast fan. In the column Bus Reset by Module Active, we can select if the bus will be reset if a module becomes active. This function is very handy to avoid user mistakes on the user interface. For instance, you can imagine when activating a PFL, the signal is heard independent upon settings of the fader and on switch. In case the fader is moved upwards unintentionally, the signal will also be heard on air, while we only had the intention to pre-fade listen and were not aware of the mistake we made. Now if we program the module reset to yes, which we did with the PFL bus, the situation is that when this module is active, the bus will be reset. So all active modules on this PFL bus are deactivated. In this way, we always can hear what's on air and less user mistakes will be made. In the final column labeled console, we assign which bus belongs to which user interface or mixing console. In this demo we have assigned bus 1 to 16 to console 1, bus 70 to 24 to console 2, bus 25 to 30 to console 3, and bus 31-32 to console 4. In this setup we could use console 4 as a virtual console with on-air bus to switch this console to 4, or a feed-through as a non-stop signal to on-air. This page assigns the real mix buses of the mixer, and by clearly labeling we can easily find it back in the system, and we give it here the functionality we want for a bus.